So let us look at another example, calculating the length of a line. And there's the official formula, D, or sometimes they use L. So D representing distance, I guess, and L represents length of a line. Alright, so the length of the line, the formula, square root x2 minus x1 square plus y2 minus y1 square. Now, before we go to the formula, let us use Pythagoras theorem and see what happens. For us to use Pythagoras theorem, we have to create a right angle triangle. I must create a right angle triangle there. Yes, and then create another triangle line here. So now we have a right angle triangle. And of course, let us call this, we can call the hypotenuse D. Let's call it D, just for it to match with the formula in terms of the notations we are using. So I'm calling this D, which is what we want to find. Just change the ink, change the color of the ink here. Alright, we want to find D. So if I'm using Pythagoras theorem, I would need the length of the other two sides square. Let's deal with the length of this side. So from here to here is 4. From here to here is 4. And then from here to here is 2. So the base is 6. And you can count the squares and see if I get 6 units. And the height, how many squares we have here? 1, 2, 3, 4. So the height is 4. Sorry, the height is 4, right? No, that's 4. 1, 2, 3. It is 4. The height is 4. 4 units. Good? So this is 4 units. No, I just realized it's not 6. Well, it is 6, the base. But the height we're counting by 2. So here to here is 1. This is, so every 2 units, every 2 blocks represent 1. So here to here is 1. So 1, every 2 blocks represent a unit. Alright, based on the scale you're using here. Alright, based on the scale you're using, 2 blocks then count by 1, 2 blocks then 2, 2 blocks then 3. You see what I'm saying here? So based on the scale, this is 1, this is 2. So this is 2 units. Double check to make sure this is 6. Yes, so 6. If you check it, you should get 12 boxes, which represent 6 units. So the height at the base is 6 and the height is 2 units. Alright, based on the scale card. The height goes from when y is 1 to y is 3, right? Okay, so that's 2. So using Pythagoras theorem, D, let me use it. I'm going to use them simultaneously. So if I'm using Pythagoras theorem says square, it's a hypotenuse square, is equal to x square is equal to the base square, which is 6 square, plus 2 square. So to get the value of D, let me do it another way. To get the value of D as take the square root of both sides. So D is the square root of 6 square plus 2 square. Alright, since D square equal to that. Let me come here and using the formula simultaneously, because the formula is actually Pythagoras theorem you're doing. Probably a lot of you probably just don't realize. Alright, using the formula says x2 minus x1. Alright, what should I call x2? Let me call this x2. So this is x1, y1, and this is x2, y2. Right? So the formula says x2 minus x1 square. Alright, let's deal with x2 minus x1 square. Now x2 is 4. So it's actually 4 minus x1, which is 2, which is negative 2. X1 is negative 2, right? So it's x2, which is 4, take away x1. And x1 is actually negative 2, plus y2 is 3. Take away y1, what is y1? 1. So coming forward, so d will be equal to, just separate it. D will be equal to the square root of what in the bracket here? What's 4 minus 2? Positive 6, right? Because the double negative here give us 6, so 6 square plus, that's 3 minus 1, 2, so 2 square, which is the exact same thing. Alright? So 6 square plus 2 square, 6 square is 36, right? And 2 square is what? 4. So this is really 36 plus 4, which is the square root of 40. Likewise, 6 square is 36, 2 square is 4, so square root of 36 plus 4 is square root of 40. That's what d is, square root of 40. And whatever that comes to, what's the square root of 40? Let me just check my calculator to get the exact units. Square root of 40, where's my calculator? That should be 6 point something, right? If I'm using 2 decimal places, 6.32 units. Well, and that's the 2 decimal places. And this root 40 will give the same result. Alright? So it's up to you. But normally in exam, sometimes you're not given a graph, or sometimes you're given some points where maybe some large points where it may be difficult to do a graph. So the formula is very important to know the formula, because it's very useful. Because suppose the points are, let's say the points are, say for example, 1, 10, and the next point is, let's say the next point is 20, 50, or something like that. Good? Yeah, so there are some large numbers. You don't want to be wasting time drawing up a graph paper for especially in an exam situation. So the form is very useful. I just label x1, x2, x1, y1, sorry, and x2, y2, and then use the formula and go ahead. Alright, so the formula, don't discredit the formula. It's very useful, especially when you're dealing with very large numbers. I just do this to show that really the formula is still basically an application of Pythagoras theorem. Let's move now to gradient of a line in our next video.